Continuation of the topic Cauchy-Euler homogeneous differential equation. It's another example to gather your concept in the Cauchy-Euler homogeneous equation. It's the last example for Cauchy-Euler homogeneous equation. If we consider this example, x squared d squared minus xd plus 2y equals to x log x. So according to Cauchy-Euler, it says that first we have to realize that this problem belongs to Cauchy-Euler because its variable, its coefficient is variable, as well as the order of the differentiation equals to the power of the variable coefficient. So it's become the Cauchy-Euler homogeneous equation. When it's become the Cauchy-Euler homogeneous equation, first we consider how can I substitute this quantity in such a manner it becomes to constant coefficient. For that reason, here we consider this one. Okay, x is e to the power z, z equals to log x, and d dash equals to dz dx. Here we consider d dash stands for ddz. So x square d square reduced to d dash into d dash minus 1. We have already learned in the previous lecture. xd reduced to d dash and 2 becomes 2. Since here we consider x suman e to the power z, x equals to e to the power z, therefore z is log x, so you can write log x is z and x is e to the power z. So the equation reduced to that form. After calculation of this step, the problem reduced to that form. So first we have to find the auxiliary equation because it becomes a CFPI problem or D operator problem. Auxiliary equation you can find just to replace d dash by m. The auxiliary equation reduced to that form: m square minus 2m plus 2. When we solve this quadratic equation using Shidharacharya, the value of m is 1 plus minus I. So it's the form of alpha plus minus alpha plus minus I beta. Alpha plus minus I beta. So beta, here alpha is 1 and beta is 1, so the CF becomes e to the power alpha z. Alpha is 1, a cos beta z, beta is 1, plus b sin beta z, beta is 1. So if we replace or substitute z in terms of x, because original variable is x, so z becomes log x, so e to the power z becomes only x, and this z tends to log x. This z reduced to log x. A and b are arbitrary constant. Next we find the pi. When we find the pi, particular integral, in that case this one becomes d dash square minus 2d dash plus 4, because this one is the function of d, this one is the function of d, so this one is the function of d. Okay, so it reduced to in this portion, and the right hand side becomes e to the power z into z. Okay, so e to the power z into z. So pi becomes f d z into e to the power z. This becomes this distance to this portion, d dash square minus 2d dash plus 2, and e to the power z into z reduced to here. Okay, so the norms is, when we find if e to the power x into v, again we repeat the norms 1 by fd, 1 by fd, the norms is 1 by fd e to the power az, e to the power az into z, the result reduced to e to the power az out from the operator, e to the power az out from the operator, and 1 by d is replaced by f d plus a, f d plus a, f d plus a into z. Okay, this one is the norms. Here we apply these norms. Okay, that means d dash replaced by, here a is 1, d dash plus 1 whole square minus 2 d dash plus 1 plus 2, and ez should be out from the operator. Okay, so in the next step, same is, I've already said, e to the power z 1 by d dash plus 1 third whole square minus 2 d dash plus 1 plus 2 z. After calculation, it's become d dash square plus 2 d dash plus 1 minus 2 d dash minus 2 plus 2, so it reduced to d dash square plus of 1. So when we change the position of the denominator, it's become 1 plus d dash square whole to the power minus 1. When we expand this as a binomial expansion, 1 plus x whole to the power minus 1 expansion, this becomes 1 minus d dash square plus d dash to the power 4, and so on. The question is why we not mentioning the quantity, why we not mentioning d dash to the power 4, because the power of z is 1. So when we expand this one, when we differentiate this one, that should be differentiated up to 1 times. So the result becomes e to the power z 1 into z, that becomes z minus d dash squared z, that means differentiation of z to 2 times. So the first times is 1 and the second times becomes 0. So e to the power z, we reduce this one as function of x, e to the power z becomes log x, and z becomes log x, and e to the power z becomes x. So the complete solution becomes, this one is your CF part, x into a cos log x plus b sin log x, and this one is the pi part, that is the complete solution of the given differential equation. So in the next lecture we move to the topic simultaneous differential equation. Okay.